Decision tree is a type of classification algorithm mainly used for classifying the task. It's kind of a decision tree is kind of a supervised machine learning technique that is mainly used for classification. Sometimes it is used for regression also, but mainly it is used for classification. It is preferred for solving the classification problem mainly, and it is kind of a tree structure classifier where internal nodes represent particular features, a particular set of features of the data sets, and the branches they represent the decision rules, right? How we are segregating them. The branches they represent the decision rules, how we are segregating them, and each leaf node represents the outcome. Each leaf node represents the outcome. Structure looks as presented in the figure. You can see that's my decision node. That's called a root node, and then I can take a decision, some sort of set of rules, and divide that tree into the divide that sub branches. You can see the decision node, and after that, that's the second set of root node, and then you can see sub tree. Then you apply the rules here, segregate them into the leaf node. Similarly, here this side also, that's another branch of my another branch. In decision tree, there are two nodes which are the mainly they are known as the decision node and the leaf node. Two types of nodes which are known as decision node and leaf node. We can see the main node, root node, where we are applying the decision rules, and then we are going down across the branch, and where we reach at the end as an outcome, that's called a leaf node. Decision nodes are generally used to make any decision and have multiple branches, whereas leaf node are the output of those decisions, and they do not contain any further branches because that's the dead end. That's what we wanted to get, and we got it. So that's my leaf node. The decisions or the tests are performed on the basis of features of the given data set. It is generally a graphical representation of getting all the possible solutions to a particular problem or decision based on the given conditions. We apply different conditions, we divide them into the branches, we try to segregate the outcome at the end in terms of leaf nodes. That's the basic idea of my decision tree algorithm, which is mainly used for classification, and it's kind of a supervised machine learning algorithm. Supervised machine learning algorithm. It is called a decision tree because similar to the tree, it starts with a root node and which expands further into the branches and construct a tree like a structure. That's why we call it a decision tree algorithm. In order to build a particular tree, we have to use a cart algorithm, CART, which is also known as classification and regression tree algorithm. The libraries should be available. See, all these problems, their libraries are available in the coding platform. You can use those. A decision tree is simply ask a question like based on yes or no answer, and then further split them, whether let's say you want to go a particular restaurant, you go to this particular branch and eat few items, or you don't want to go, let's say, veg non-veg restaurants, right? So if you want to go for a veg restaurants, then you can come up here in that particular branch and you eat the veg items. Or you want to go to the non-veg restaurants, then you go in a non-veg restaurants, and then you explore more number of things. Then furthermore, maybe different non-veg items which you want to order, then you can say, like, let's say fish, chicken, or maybe something else, and then there are multiple branches of them, and then you can eat them. Why we use decision tree algorithm? Like decision trees usually they mimic human thinking ability while making a decision. They mimic human thinking ability while making a decision. So that's why it's easy to understand also. The logic behind the decision tree can be easily understood because it's like a tree like structure, so it's easy representation can be given using this. Some of the terminology, such as let's say a root node, uh, is a node from where we start our decisions, and it represents the entire data set, which further gets divided into two or more homogeneous sets, right? Two more branches of trees. A leaf node is a final output node, and further after that point, the tree cannot be segregated further once we reach the leaf node. That's called the leaf node. Splitting. is generally a process of dividing the decision node or root node into the sub nodes based on the given conditions or set of rules or our decision rules, what we are looking for in that particular sub branch. A branch or subtree is like a tree formed by splitting, right, based on our decision rules or set of rules what we have given the conditions. Sometimes there would be some kind of unwanted nodes or branches in a particular tree, so that can be removed through pruning. So pruning is a process of removing unwanted branches from the tree. Just to simplify the tree structure, we don't want to make it complex, so we do sometimes the pruning, so it reduces the complexity. Parent slash child node, the root node of the tree is called a parent node, and once they are divided, the other nodes into the subtrees, they are called the child nodes. They're called the child nodes. How this algorithm works, the workflow, the major workflow. In a decision tree for predicting any class of a given data set, the algorithm which will start from a root node of a tree, and this node will compare the values of the roots attributes with the record or the real data sets, and then based on the comparison, it will follow the branches and jumps to the next node. Such as, let's say this is my decision node, and then based on my criteria, it will segregate them into the branches. It will segregate them into the branches. For the next node, the algorithm again will compare the attributes, their values, and with the other sub nodes and move further. So it will continue that process until it reaches the leaf node of a tree, right? So you keep applying the set of rules, keep dividing them into the branches, and then when you reach the leaf node, we stop there because that's what the outcome we were looking for. The major steps. First step is to begin the tree with a root node, say let's say S, and which contains the complete data set. Entire data set will come. Step number 2 is to find out the best attribute in the data set using the attribute selection measure, ASM, attribute selection measure. Using them, we will try to identify the attributes. Step number 3 is to divide that root node as or into the subsets that contains possible values of the best attributes. So it's like a splitting here, divide them into the multiple branches, generate the decision tree node, and then which will contain the best attributes. Step number 4. Step number 5, recursively make new decision trees using the subsets of data sets and which are created in step number 3, and continue this process until the stage when we reach and when we cannot further classify or divide the nodes, and then we reach the leaf node or final node, right? So that's my final outcome, expected outcome. So that's how this algorithm works. Like such an, let's take one example to understand. Such as, let's say, suppose there is a candidate, right, who is looking for a job, and the candidate got multiple job offers. Let's say a job offer, and he wants to decide whether he has to join or not. He wants to accept or not. So let's say first decision, how to solve this problem. So let's say first he has to make a decision. I got, let's say, 2 jobs or maybe multiple jobs, correct? So he has to solve this problem and make a decision. So he will start the decision tree. He will start the decision tree at a root node. Let's say the major attribute is like here, ASM, major attribute is like here, is a salary. We will look at the salary first. What's the package? If the package is highest, then we gotta see that, okay? So let's say if the package is not meeting my expectations, I am going to say no, and I'm going to decline that offer, right? So that's my leaf node here in that particular tree. If I enter in that particular tree, now let's say they are matching the expectations, right? So it went to the next level. That money, we are satisfied with the salary, we are what they're paying us, we are satisfied with the paycheck. Now what we wanted to do is we wanted to go and split the root node further into the multiple branches for a next level of decision. What am I going to see is which city is it? Is it nearby the home? Is it my hometown? Is it my home state? How many hours I have to commute, right? So let's say it's not nearby my hometown or nearby my home. I'm going to say no, and I'm going to decline the offer because let's say kids are settled down, or maybe I'm settled down to a hometown, or maybe your family settled down to a hometown. You don't want to go far away from the hometown. Then we are going to decline that particular offer. Now let's say it is in the home state or home nearby the hometown. Next level of decision, what we are going to say is Is there a cab facility or not? Is there a cab facility or not for commuting daily? For commuting daily, let's say no, then I am going to say no, I am not going to accept it. Or maybe you can say, okay, I can manage, and even if the cab facility is sometimes not available, I can, if the transportation allowance is given, I can make my own arrangements. In that case, this branch gets eliminated, right? So it comes says that if cab facility is available, I'm going to accept the node here, accept the offer here. If the cab facility is not available, what am I going to do is I'm going to look for the transportation allowance, and then I'm going to say if transportation allowance is there, I can arrange my own cab to commute, then I can accept the offer. So in that case, in that way we move on. Or we can say no also, that if it's far away and if the cab facility is not available, I may not join. I may not join. So in that way, the decision tree works. In that way, the decision tree works. How we do the ASM, attribute selection measure, how we do the ASM, attribute selection measure. While implementing a decision tree, the major issue arises that how we select the best attribute for the root node, and accordingly we can split them for into the subnodes. So to solve such problem, to solve such problems, there is a technique. There are multiple techniques are available. There is one technique which is called attribute selection measure, or ASM. By this measurement, what we can do is, like, we can easily select the best possible attribute for the node from the tree, and and then there are two popular techniques in ASM, such as, let's say, information gain in ASM, such as, let's say, information gain and Gini index. Information gain and Gini index. These two techniques, we can extract the major attributes for selection, and we can split the root node into the subnodes. We can split the root nodes into the subnodes. Let's say information gain. What is information gain? What is information gain? Information gain is a measure of the changes in the entropy after the segmentation of a data set, based on a particular attribute. So it calculates how much information how much information a feature provided us about a particular class, right? Wow, particular class. According to this particular value of the information gain, what we are going to do is we are going to split the node and build the decision tree. Split the node and build the decision tree. Generally, the decision tree algorithm always tries to maximize this value of the information gain. That if I have a maximal information gain in that particular split, I'm going to split it in that particular direction and create a tree. And information gain is maximized, then it will and a node attribute having the highest information gain will be splitted first. So once the information gain is maximized, it will see that the particular attribute slash node which is having the highest information gain, and then I'm going to split that in that particular branch. And generally, the information gain is computed using this formula, such as, let's say, information gain equals to entropy S minus weighted average into entropy of each feature. Right? Using this formula, I try to compute my information gain, and my major objective is to maximize the information gain in that particular branch or tree. Right? What is entropy? Entropy is generally a metric. Entropy is a metric to measure the impurity in the given attribute. Impurity in the given attribute. It specifies a randomness in the data generally, and then it is measured using this particular equation. ES equals to summation of I equals to 1 to C minus pi into log pi. Right? So let's say if I am entropy of playing a particular game, maybe cricket or maybe golf or anything, right? So entropy, let's say entropy is like 5,9. So let's say if there are 5 times I am not going to play the golf or any game, or 9 times I am going to play. So I say yes 9 times, 5 no, right? Yes for 9 times and 5 times for no. So 5, 9. So entropy is like, let's say, given as 0.36 is the probability of saying 0.36 is the probability of saying no, and 0.64 is the probability of saying yes. So P1 is, or you can say P yes is the probability of saying yes, which is 0.64, and P no is the probability of no, which is 0.36 here. So using this formula, I can say pi into log base 2 pi. So it's like 0.36 into log 2 0.36. That's the first minus sign is there, and then minus 0.64 into log or 0.64. So this is for the yes, and this is for the no, and total entropy I get is 0.94, right? 0.94, which can be extended here also. You can say entropy equals to minus p yes for playing the golf into log 2 p yes for playing the golf. These are the probabilities of playing the golf, and minus p no playing the golf, and log 2 p no for playing the game. These are the probabilities of that's the probability of saying no for playing the golf. And then that's my entropy. Entropy, then I substitute here, and then I can compute the weighted average into the entropy of each feature. That's the given, and then the weighted average is it can be extracted from it. And then what we find out is like entropy, and we try to maximize this information gain. We try to maximize that information gain, and we try to split into the tree. We try to split into the tree. So that's how the entropy is measured and split is created. Next important method is like based on the Gini index. Generally, Gini index is a method of impurity or priority used while creating is Gini index is a measure of impurity or purity, which is used while creating the decision tree in the CART classification and regression tree algorithm. Right, and this is an attribute with low Gini. If this Gini index is so, like that's an attribute with the low Gini index should be preferred as compared to the high Gini index. What we try to say that always the impurity should be as least as possible, as least as possible, right? So my Gini index should be as least as possible. On the contrary to the information gain, what we have seen in the on the previous slide, it always creates the binary split, and the CART algorithm uses the Gini index to create the binary split. Gini index can be computed using this. Gini index can be computed using this formula, and then what we try to look for is like the minimal value of the Gini index, when we try to split. Pruning, it's like sometimes that's another method to reduce the complexity. It's like getting an optimal decision tree, optimal decision tree. So pruning is a process of detecting an unnecessary nodes from the tree in order to get the optimal decision tree. And sometimes we get too large tree, which increases the risk of overfitting. And a smaller tree may not capture. Sometimes the tree is very small and it may not capture the important features of the data set. Right? If tree is too large, overfitting is the trouble. If tree is too small, it may not be able to capture the features of the data sets. Therefore, technique that decreases the size of the learning tree without reducing the accuracy is known as the pruning. We try to cut down some of the nodes or some of the sub branches which are not of any use. That method is called the pruning. So the formal definition is a technique that decreases the size of the learning tree without reducing the accuracy is known as pruning. There are two major types of pruning technology. There are two major types of pruning methods, such as let's say cost complexity pruning, and reduced error pruning, right? So let's say one small example. Here. I can take, let's say, unpruned decision tree. This is an unpruned decision tree. You can say let's say income is greater than 30,000, right? Income is greater than 30,000, then that's the tree. Income is less than 30,000, then that's the tree. Let's say a person, if his income is greater than 30,000, is he looking for the loan from the bank? Yes, then he gets the loan. No, then further is like divided into the further sub branches, correct? And then further it's divided into sub branches. Similarly, you can see if there is a criminal record. If there is a criminal record, then no loan would be given. Then it's like a further it can be splitted into the multiple parts of it. Now let's say some of the nodes here. See, if the income is 30,000, person is not looking. So it's like a income is 30,000. We do not want to give them a loan because most likely he may not be able to repay the loan, right? May not be able to repay the loan, or we can give a smaller loan to them, not a huge loan. So now this entire further check is not of any importance. is not of any importance. So what I can say, no loan. That's the end of a tree. So complexity is reduced further, right? If he's looking for the loan, then we can go and see the further sub branches, whether what kind of documents are needed, right? So it's like a what kind of documents are needed, and then so on. We can see further. We can see further. So here you can see other loan from the same bank, and then so see if there is another loan from the same bank, then that's the loan here. We are not going to give them another loan. And if there is no loan taken from the same bank, what we are going to do is we are going to say, are there any documents that we need? If yes, I mean all the documents are satisfactory, then we give the loan. And if let's say all the documents which are required, which are not satisfactory, then we'll say no. So you can see at a recap, I can see if the income is 30,000, we are going to give them a loan. We are going to check their records, documents, whether the person is already holding a loan. Then we'll, yes, then we'll not. We'll say loan. You repay the current loan first. We're not going to give you a new loan. Let's say he's not holding a loan from the same bank. Then they're going to say, give us the documents. If all the documents are satisfactory, you get the loan. If no, you won't get the loan. Right here, you can see below 30,000, we don't need to check them at all. We don't need to check them at all. We don't need to check them at all, and we can say no loan. So the loan is not given. So here you can see based on my splits decision rules, I have this larger tree, and then further I can prune my sub branch here. Further I can prune my sub branch here, right? Further I can prune my sub branch here. That's called a pruning. That's called a pruning. So there are certain disadvantages and advantages of the decision tree algorithm. There are certain disadvantages and advantages of the decision tree algorithm. Firstly, the advantage is like it's simple to understand as it follows like a tree structure, like a human thinking process. So it's easy. It's linked with the real time, real life experiences. So it's easy to understand. It is very useful for solving decision related problems. That's the advantage. It is very useful for solving the decision related problems. It helps to think about all possible outcomes of the problem, right? All possible outcomes, because there are multiple branches of the trees and they are divided into the multiple branches. So generally what we get, it'll try to identify all possible outcomes of the problem. So there is a less requirement of the data cleaning here compared to the other algorithm, because of based on the ASM attributes, it will divide them, and then cleaning is like least required. There are certain disadvantages of the decision tree, such as decision tree contains lots of layers, which makes it more and more complex, because we have to apply the decision rules across them, and then there are multiple branches, so it becomes highly complex. It may have an overfitting issue here. It may have an overfitting issue here, which can be solved using the random forest algorithm, which can be solved using the random forest algorithm. In random forest algorithm, what we do is like we have multiple of trees running in parallel, and we take the average of all those trees, and then we can see. Now that we have seen in the real lectures, the basics of the random forest algorithm. For more class labels, the computational complexity of the decision tree may increase. The computational complexity is larger naturally because it divides them into the multiple trees. So that's why the computational complexity is extreme in this.